Hey everyone, so welcome back to my channel again, Intelligent Learners. In this video, we are going to find out the common difference T. Now, what is a common difference? It's just the difference between the two consecutive terms in a sequence, right? In an arithmetic progression, the difference between the two consecutive terms is always same, right? That is the common difference. Now we have the sum. What is the given part in the question is the sum of the n terms of AP, which is equals to Qn Pn plus Qn square. This is the sum. So we are going to use the formula for sum of n terms of AP, right? Which is n by 2, 2a plus n minus 1 times d. So yes, let's start the video everyone, because in this question, we have to just equate the right hand side with the left hand side, because nothing much we have to solve in that, okay? So yeah, let's start the video everyone.
In the question is if the sum of the n terms of AP is arithmetic progression. It's a sequence in which the difference between the two consecutive terms is same, right? The common difference between the two consecutive terms, they are same. So sum of n terms of AP is given to us, that is this one. So we know that when we are talking about AP, so A is the first term, small d is the common difference between the two consecutive terms. And here we are talking about the sum of n terms. So total terms we have in an AP is n. And when we are talking about the sum of n terms, so there is a general formula that is equals to n by 2 2a plus n minus 1 times d. Now we don't know the common difference. We don't know the first term. We don't know how many terms are there. So exactly everything is same only. We are using this formula, but we have the sum. So under sum, what we will write the sum only. Okay, so let's move to the new page to understand it very clearly. We don't have anything and we have a single equation. So what is the sum you have in the question? That is Tn plus Qn square, that is equals to n by 2 2a plus n minus 1 times d. Okay. Now we have to do one thing. So Pn plus Qn square. Let's open the bracket. So when I multiplied n by 2 with 2a, so 2 cancel out, na is left plus. Then I will multiply n by 2 with this one. Okay. So let's take the step further. So Pn plus Qn square, that is equals to Na plus. Now I'm multiplying n by 2 with n and also with d. So it will be n square by 2d minus n by 2 with 1 and with d, which is n by 2d. Now we don't have any other option to do. Now let's do one thing, that this side is equals to the right hand side, right? Left hand side is equals to the right hand side. So we can compare the coefficients here. So let's compare. What we will do, we will compare the n square power with the n square. Okay. We can do that. Or what you can do, you can just compare n with n also. Okay. So you can compare these two also. It's your choice. You can compare. So let's compare it. So when you will compare n square with this, and I'm just comparing one, either you will compare with the n terms, because this is also n, this is also n. So you have to compare Pn with both. Okay. Or what you can do, one thing, you can compare directly n square with the n square. So I'm comparing the n square coefficients. So this one, right? So n square cancel out. So 2 I'm taking in the left hand side, which will be in multiplication. So 2q is equals to d. Okay. So this will be the value for the d. If you want to compare the n parts also, because here we have Pn, and if you want to compare n coefficients, so you have to compare this whole part. And so it will be in the form of P and n, because cancel out, because I will take n common. So it will be a minus d by 2. So I can take a to the left hand side and d by 2. Now I'm taking 2. P minus 2a, that is equals to minus a. D will be equals to 2a minus 2p when I will take minus common. So either the value of d is this or the value of d is this. So because q is a constant, p and q are constant, so I am taking it this. So this is as simple as that, in the form of p, or you can take d in the form of q also. It's your choice. Okay. So yes, thank you everyone. Thank you so much.